Morning, guys. See here, this is the class regarding chemical bond, the part 2, which we are going to do whatever is called here in this session. The calculation of sigma and sigma bonds as well as lone pairs. After that, we should find out what's called here the shape of the molecule, geometry of the molecule, geometry as well as shape. That comes under as well as hybridization and VSEPR theory. Hybridization and VSEPR theory is concerned. Now children, whether you solved or not, let us do this. The Br is going to be a 17th group element. Fluorine is also going to be 17th group element. Therefore, it's what we are going to do. N is equals to, for BRF3, what we are doing is going to be, how many are there? 7 plus 3 into 7 by 8. It's 21 and 28. That's giving us what you know as here 28 by how much? 8. It's going to be 28 by 8. So this is going to be 3. The remainder is going to be 4. And M is equals to R by 2. So that it's going to be 3 sigma bonds, remainder is nothing but 4 by 2. So that it's going to have 2 lone pairs of electrons. 2 lone pair of electrons here. So that the general formula of this one is going to be AB3L2. AB3L2 children. Are you getting? And next coming to that, we will come for BRF5. BRF5. How do you solve this? Number of sigma bonds, bromine is 1, fluorine is 5 into 7 by 8, 35, 42 by 8, Baba here. It's going to be by 8, it's going to be 8 5s are, it's going to be 5 sigma bonds, and or else you can say bond pairs also children. That's going to be having, remainder is 2. Then M is equals to R by 2. 2 by 2, it's what's called here 1. 1 lone pair of electrons with respect to what's called here BRF5 is concerned. And this is BRF3. What we have done? 3 sigma bonds, 2 lone pairs are going to be got here. Let's go for another example also. That's which we have done. Xenon trioxide. And after that children, we will do how to find out its shape, how to find out its hybridization. Hybridization is nothing but geometry, and shape is absolutely based on bonded atoms as well as lone pair of electrons. In fact, it is going to based on lone pair of electrons. You know pretty well children, xenon is 18th group element, 8. 3 oxygens are going to be 3 into 6, 6th group, it's going to be whatever is called 16th group by 8. It's called 18. 18 plus 8, how much you are getting, Baba? 26 by 8. It's going to be 3. M is equals to 2 by 2. It's going to be 1. So that it's having 3 sigma bonds and 1 lone pair of electrons. It's going to be 1 lone pair of electrons. See here children, and after this I'll go for whatever is called N and M, how it is going to predict geometry, how it is going to predict shape. The molecule is going to be comes under AB3L. AB3L. Because it's having 1 lone pair, no? And let's go. Another one, xenon tetroxide. Coming to this, N concerned, number of sigma bonds are concerned, 8 plus 4 into 6, it's 24, 6, whatever is called here, 32 by 8, it's 4, so that it's going to be, remainder is 0, therefore M is equals to 0, as the molecule comes under AB4L0. AB4L0. Okay children, after finishing this also we are going to do with ICl2 minus 1, ICl2 plus 1. How can you solve this, children? Let me do this also. After finishing this, we will go for the next phase, that's going to be finding geometry. That's nothing but our hybridization. And finding lone pairs, that's nothing but predicts the shape, right? Based on VSEPR. And let's come to this, children. ICL2 minus 1. How can you find out, Baba? You speak out, children, please. This is going to be 7 plus 2 into what's called as 7. Because 2 chlorine atoms are there, minus is there, we should add 1 electron or negative charge by 8. How much you got, Baba, here? That's nothing but what is say here. That's going to be 7, 14. It's going to be 6, 21 and 22 by 8. 8 2s are 16. 2 sigma bonds you got here. That's nothing but what's called here 2 sigma bonds. And what's the remainder here? The remainder is going to be 6. And the remainder is 6 means R by 2. That gives lone pair of electrons. 6 by 2, it gives 3 LP of electrons. Z bar, yes. So that, Mama, here the compound comes under AB2L3. AB2L3. After this, we go for hybridization. Don't worry. That also having very simplest possible trick. Here, that's what we are going to do. Another. Next, we are going to do with what's called here ICL2 plus 1. How can you find out, children? So many examples I have done because you should be able to answer in the exam within no time by using this formula. And also you can predict its geometry as well as shape without any ambiguity by doing next phase of the class here. Next one, 7 valence electrons, 2 chlorine atoms, 2 into 7 and by 8. Because of positive charge, we should subtract this one. 21. It's going to be minus 1. 20 by 8. 2. It's 4 is the remainder over here. M is equals to R by 2. 4 by 2. 2 LP of electrons are present. How much? What might be this? 2 sigma bonds. N is 2 sigma bonds. Hence, we are going to have AB2L2 type of the molecule set. What are you writing AB2L2 type? L is lone base, B is bonded atoms, A is the central atom. That we are going to do in the part of next session. Now, let's finish this part also. What's called? Finally, children, better answer no. Can you try to answer this SF4? I am not asking any this. N, total valence electrons, that's going to be 6. 4 into 7 by 8. It's 28. That's going to be what's called here 6. 34 by 8. 8 4s are 32. 8 4s are 32 means the remainder is going to be, what's that, Baba, here? R by 2. R means remainder. M is equals to number of lone pairs. How many are there? 2 by 2. It's 1 LP of electrons, children. Now, can't you write the formula? This is the A, central atom. B is the bonded atom. L. Let me do this. Next phase, we are doing its hybridization as well as this one also. Last but not least, the beautiful compound comes under 17th group. Almost the fluorine is transported in this ClF3 state, right? It's a beautiful questionnaire meant for NEET and IIT. So that ClF3 is concerned here, children. What we are getting here means, let's find out once again. Repeatedly I am making you to practice, children. Don't think that it's wasting of time. It's 3 into 7 by 2. That's 21. And 7, that's going to be 28 by, 8, it's going to be 8. 3s are 24. Remainder is going to be 4. R by 2. 4 by 2. How many lone pairs? 2 lone pairs of electrons. And this is going to be 3 sigma bonds. The type of molecule is AB3L2. AB3L2 here. That's it, children. Next session we'll go for the next part to continue with hybridization, VSEPR, to predict the geometry as well as shape of the molecules in a simple and sweet manner that will be versatilely useful for you in all categorical exams. Okay, thank you all.